Hello everyone, welcome to the video on logical interpretation of infrared spectrum. Now I'm attending a workshop on spectroscopy in Andhra University, and the lectures are being conducted by Dr. M. Murali Krishna sir. So whatever the inputs I'm giving in this video are from his lectures only. They are really helpful. Now let us understand about infrared spectrum. See, atoms are connected with bonds, and the bonds are because of sharing of electrons in covalent bonds. Now these bonds will have certain frequency and they will be always moving with certain frequencies. So when infrared radiation of same frequency falls onto this bond, the bond will absorb the radiation and stretch or bending vibrations occur. This is what is the basic principle of infrared spectroscopy. Now, what frequency is absorbed is based on Hooke's law. Hooke has given two major parameters to determine what frequency of light is absorbed. One, the frequency is proportional to bond strength. If bond strength is more, higher frequencies will get absorbed. Now, when bond strength is more, the frequency with which the movement of the vibration of the bond occurs is very high. So it takes higher frequency radiation, and that occurs at higher energy levels. This is one factor. Bond strength is directly proportional to the frequency absorbed by this molecule. The second one is reduced mass. So the absorption of the higher radiation is inversely proportional to square root of the reduced mass. Now understand this one. See, reduced mass means if two bulky atoms are attached, the vibration frequency is reduced, so they absorb at lower energy infrared radiation. So only these two factors we need to consider: bond strength and reduced mass. Bond strength is directly proportional, reduced mass is inversely proportional. So this is the basic principle. Now, when you see the infrared spectrum, on the x-axis you have wave numbers which are given in per centimeter. This is for our convenience. For y-axis you have percent of transmittance. So the range is from 4000 per centimeter to 500 per centimeter. Now this entire range can be divided into two groups. From 4000 to 1500, it is considered as functional group region, wherein most of the functional group absorption you can observe. Whereas from 1500 to lower range, 400 or 500, it is considered as a fingerprint region. Now, in this video, I will explain how this functional group region can be divided for the convenience of IR spectra interpretation. This zone can be divided into 5 groups. Now, the first group is called as zone 1. The zone 1 is from 3700 to 3200 per centimeter. See, understand this, wavelength is directly proportional to frequency. So the higher wavelengths correspond to higher energy, whereas lower wavelengths correspond to lower energy. From 3200 to 3700, higher wave numbers correspond to higher frequency. Now at this region, the stretch of OH, NH and triple bonded carbon with H, all these stretches occurs at this higher wave numbers. Now you need to understand the reason is, see, OH NH bond strength is high, and a bigger atom like O is connected to smaller atom like hydrogen. So this results in reduced mass is decreased. And what happens with this? When reduced mass is reduced, the frequency at which it absorbs increases. So both the factors are there. Bond strength is high, reduced mass is low. Both of them will enhance the frequency, and because of that, higher frequency is absorbed. That is the reason why you see the absorption of this OH, NH and triple bonded carbon with hydrogen at 3200 to 3700. Now understand about CH bond. See, when it is triple bonded or acetylenic, the hybridization is sp hybridization. Sp hybridization, the bond length is shorter. When the bond length is shorter, bond strength is high, and because of that, the absorption occurs at higher frequencies. So this is about zone 1. Now coming to the zone 2, zone 2 is from 2700 per centimeter to 3200. Now at this zone, you will see allylic, vinylic, or see carbon with hydrogen bonds. We have seen sp hybridized carbon with hydrogen bond absorption occurs at higher wavelengths, 3200 to 3700. The remaining double bonded carbon with hydrogen bond or single bonded carbon with hydrogen bond will fall under 2700 to 3200 per centimeter wave numbers. Now again, a tip given by Murali Krishna sir is draw a line at 3000 per centimeters. Anything above 3700, from 3000 to 3200, you will see the bond stretch of carbon hydrogen. The carbon should be bonded with sp2 hybridized carbon. See, sp hybridized carbon, the bond length is very short. sp2 bond length is little longer, so it requires less energy. That's why it is coming at 3000 to 3200. Whereas sp3 bonded carbon and hydrogen bond stretch, the bond length is increased, bond strength is decreased, so it occurs 2800 to 2900 per centimeters. So this is the major takeaway. The other things, see, for carboxylic acid OH group, a big peak occurs between 2500 to 3000. Understand the logic. See, we have seen OH stretch occurs at higher frequencies, higher wave numbers, 3200 to 3700. But carboxylic OH, the absorption occurs between 2500 to 3000. A big peak is there. It is because of hydrogen bonding. Hydrogen bonding reduces bond strength, so the absorption frequency comes down, and because of hydrogen bond, a big peak occurs. So this is about zone 2. Now coming to the zone 3, zone 3 is divided from 2000 to 2300 per centimeter. Now at this zone, alkyl and carbon-carbon double bond, carbon-carbon triple bond and carbon-nitrogen triple bond, alkyne and nitrile bond absorption occurs. Now understand this one. Though they are triple bonds, the bond strength is high, but both of them are big atoms like carbon-carbon and carbon-nitrogen. Because of the big atoms, reduced mass increases. So the absorption frequency is inversely proportional to reduced mass. When reduced mass is increased, absorption frequency decreases. That is the reason why the signal occurs between 2000 to 2300. This is zone 3. Coming to the next one, zone 4 is divided between 1650 and 1850 per centimeters. Now, this zone is very crucial because all the carbonyl absorptions you can see in this big range. Again, you cannot say a specific per centimeter wave number because it varies depending upon adjacent group. In case of ketone C double bond O, you see a signal at 710 or 1750. But the same ketone C double bond O, if it is attached to OH in acid form, it goes down. I explained you already, it is because of hydrogen bonding, the absorption frequencies goes down. So this is an important reason, 1650 to 1850. Now the last zone is 1450 to 1650, wherein you see absorption stretches of carbon-carbon double bonds like alkenes, and the benzene ring carbon-carbon double bond absorption occurs in this zone. So this is the last zone wherein you have weak interactions are there. Again, though carbon-carbon double bond is there, bond strength is there, because of the bigger atoms, reduced mass increases, and at lower frequency the absorption occurs. So these 5 zones are very important for your preliminary interpretation of IR spectra. So I hope this is useful. All the best.